Hello. And thanks for watching this presentation. This publication is a continuation of the Asteroid Polynomials 2 publication. Here we will try to get a deeper look into the harbor area of the value space of this sequence, showing videos which have been created for this area from the Asteroid polynomial sequence. The first video shows the evolution of the Asteroid polynomial sequence in the harbor area, starting from index 23 and ending at index 30. It is a flat contour map representation and it applies a zoom factor of 90. Immediate after this video came some more flat contour map representation of the same era, each one incrementing the zoom factor. Let us now look the harbor area using 3D spatial representations. The first video has nearly the same parameters than the first flat contour map representation of the harbor area. It applies also a zoom factor of 90 and it runs between index 20 and 45 of the asteroid polynomial sequence. The video shows the harbor area from the right-hand side. Please pay special attention to the two big elevator areas, which at the same time are areas of deformed self-similarity. The second video once more shows the same part of the harbor area. But instead of viewing this part from the right-hand side of the asteroid object, as it was done by the previous video, now we will get a look from the left-hand side. The video applies a zoom factor of 100 and it runs between index 8 and 35 of the asteroid polynomial sequence. The third video shows an area similar to the area showed in the last flat contour representation of the harbor area. It applies a zoom factor of 1000 and it runs between index 31 and 43 of the asteroid polynomial sequence. It gives us a first idea of how the concentric ring valleys in the harbor area are constructed. To learn a little bit more of the concentric ring valley process, we will now show a video that applies a representation concept which is based on sectional views of the asteroid surfaces. The video applies a zoom factor of 400,000 and it runs between index 26 and 46 of the asteroid polynomial sequence. The section used for this video is the following. Let us now for a moment come back to the connection highways which we saw during the analysis of the header area in the publication Asteroid Polynomials 2. To do this we show a 3D spatial video using the sectional view concept. The video looks exactly in the direction of the biggest of the highways which we can appreciate in the header area. At the moment, this is the last publication of the Asteroid Polynomials publication series. Nevertheless, if we find out new aspects of the asteroid polynomials we will publish them immediately. At this moment especially we are working to obtain the evolution of the surface square meters of the subsurfaces of points of fixed limited heights generated by the asteroid polynomial sequence. First calculations indicate that these surface square meters are growing up to infinity along the asteroid sequence. Nevertheless, more extensive calculations must be done to concrete this hypothesis.